So here we have a problem that says use the graph in figure 11 to determine the following limits. We have this graph given and we're supposed to find the limit as x approaches 1, 2, 3, and 4. The general idea is that if we can find that the limit as x approaches a from the left-hand side of a function, if we can find that that is equal to the limit as x approaches a from the right-hand side of the same function, then we can conclude, these three dots mean therefore, the overall limit, the limit as x approaches the number a of f of x, is also equal to that number. Let's call that number L. If the limit as x approaches a from the left of f of x is equal to the limit as x approaches a from the right of f of x is equal to some value L, then the overall limit will also equal that value L. So in order to determine what the left-hand limit is and the right-hand limit, let's look at the graph. Let's say we're trying to find the limit as x approaches 1 from the left-hand side of f of x. So the way we do that is we find 1 on the graph, then we go towards the left a little bit, and then find the function. So once we found the function a little bit to the left of x is equal to 1, we move towards x is equal to 1, so we're going to be moving to the right, to find, once we get to where x is equal to 1, we need to see what that function value is. So the function value is approaching the y value of 1. So our left-hand limit of x approaches 1 of f of x is equal to 1. Just like that. To show the right-hand limit, let's try to find the limit as x approaches 1 from the right-hand side. The little plus means the right-hand side. The little minus means the left-hand side of f of x. We do a similar idea. We find where x is equal to 1. Then we move towards the right-hand side. We then find the function that's a little bit to the right of x is equal to 1. Then we reapproach x is equal to 1, so we'll be moving to the left to reapproach x is equal to 1. So what is this? What's the function approaching as we approach x is equal to 1? We're again approaching a y value of 1. So our left-hand limit is equal to 1. Our right-hand limit as we're approaching 1 is also equal to 1. So that means that the limit as x approaches 1 of f of x is equal to what they're both equal to, that they're both equal to 1. Notice that we have an open circle, so that means that the function value is not defined at 1, but it approaches 1 from both the right and the left. So let's try part B. That was part A. For part B, let me use a different color. For part B, we are looking for the limit as x approaches 2 of f of x. So let's first find the limit as x approaches 2 from the left-hand side of f of x. So here we find where x is equal to 2. Then we move a little bit to the left and find the function. Once we find that function, we want to reapproach 2 from the left-hand side. So we're reapproaching 2 from the left-hand side. What does that equal? It looks like the function value there is approaching 1, similarly to how it was in part A. Now that we've found the left-hand limit, let's find the right-hand limit. So we find where x is equal to 2. We then move to the right a little bit and then find where the function is a bit to the right of x is equal to 2. So that would be like here, for example. Then we move towards x is equal to 2. So we're moving to the left, approaching 2. So what value is our function approaching as x approaches 2? It's approaching a y value of 2. So this limit, so the right-hand limit is equal to 2 when the left-hand limit was equal to 1. So this time, the left-hand limit is not equal to the right-hand limit. When that is the case, the overall limit does not exist. And D&E is a abbreviation for does not exist. Let's try next part C. So for part C, we're looking for the limit as x approaches 3 of f of x. So let's first find the limit as x approaches 3 from the left. So we find x is equal to 3. We move to the left a bit, then we find the function. Once we've found the function, we approach x is equal to 3 again, and we find what the y value is of that point. So it looks like that we're approaching the y value of 2. Let's do the same thing from the right-hand side. The limit as x approaches 3 from the right-hand side of f of x. If we find 3, we move to the right a bit, find the function, here for example. Then we move towards where we're approaching 3, where x is approaching 3. Once we found where x is approaching 3, we look for the y value there, which is 2. So this time, the left-hand limit is equal to 2, and the right-hand limit is also equal to 2, so the overall limit is also equal to 2. Okay, so I hope that gave you some good examples on this one. Try letter D on your own and leave what you get for the answer for that in the comments. And I will respond and let you know who gets it right. Thanks for watching.